Let's look at the following example. So we're going to do this example. So we're given a statement said determine the volume of the solid generated when the area between the curve and the x-axis rotate about the x-axis, rotate about the y-axis. Okay, if they say rotate about the x-axis, that means it's Vx, and if they say rotate about the y-axis, it's Vy. And then when they are looking for volume, and then the equation is this one, 2. So the boundaries is this one and this is supposed to be the y-axis, not the x-axis. Okay, and then this is the boundary, this is the boundary, and then we are given this equation. This equation, it's a parabola, but it's in the y-axis. So first thing first, let's determine the graph. We let x equals to 0 and then solve for y. And then you will have something like then y equals to 0 or y equals to 3. And then from here we have we're going to solve for x. So x, when y is 0, x is equals to 0. When you put 0 here, 0 here, you get 0. So you just let y equals to 0 and then x equals to 0. Then another thing, because it's a parabola, you have to calculate the turning point. We'll have y equals to and then what is the value of b? B is 3, so it will be negative 3. And then a is negative 1. So we have a turning point of 1 comma 5 in the y-axis. And then when you solve for x-axis, you take 1.5 and substitute it here. What do you get? So we have a square of this one and 3 times that one, so we'll have 3 over 2, which is 3 square, it will be 9 over 4. And then 3 times 3, it's 9 over 2. So here if we got I have 2, let's take 9 as a common factor. We'll have 1 over 2 minus 1 over 4. Then you'll have as the turning point 9 over 4 is a turning point in the x side, so we'll have a turning point of uh, and then from here you can sketch the graph. This is the y-axis, x-axis. So that's it, that's the graph.